This lesson is going to look at finding angles with sine, cosine, and tangent. You're going to find it very similar to the way we found sides. So our objectives for this lesson is to determine the trig function for given angles using sine, cosine, and tangent. And I guess I made a mistake here. It should say to solve for unknown angles using the correct trig function. Okay, so that's our main goal for this lesson. Make a quick note in there. All right, so we're back to, this is just the triangle we had last day. So just a quick reminder of how we label. So we'll call this our subject angle down here at the base. We're very clear with a right angle here in the corner. Typically, if you have a right angle, it'll be given to you and told. Most of the time you don't want to assume, but occasionally if I'm writing questions out, it's a little harder to write in. Opposite the right angle is always our hypotenuse. Okay, now across from the subject angle is opposite. And then we have adjacent next to the angle. So just a quick refresh, remember those three. The other key thing we're going to find in this lesson is all angles sum to 180. Okay, so in a triangle, all of your angles sum to 180. That's one other little piece that we'll want to remember by the time we get to our fourth example. So just a quick reminder of the three ratios. We have a sine ratio, so that's our SOH, S-O-H. It uses the opposite side and the hypotenuse. Cosine, or ca, uses the hypotenuse and the adjacent side. And tangent, TOA, uses opposite and adjacent. It doesn't use hypotenuse. So remember those three ratios. And then remember the way we write it out. We do sine of an angle. We always want to keep that angle symbol there because we're going to, this lesson, we're going to be actually putting a number there. Or finding what number goes there. So sine of an angle is equal to the opposite divided by hypotenuse. Cosine of an angle is our adjacent divided by the hypotenuse, and then tangent of an angle is equal to the opposite over adjacent. So just remembering how you write them out. This is a great little visual. If you need something to have on hand just for quick reference, this is a good little visual to use. So I'm going to begin with a quick calculator check. This is a nice, easy calculator check. We just want to make sure, can you do the function that you're required to for this lesson? So just like in your last lesson, I asked you to please make sure your calculator was in degrees mode. So you had some practice doing that. So take a look at the top of your calculator. You want to see if you have the solar calculator that is used for the block exam. You want to see that it says DEG up at the top here. If you have my favorite calculator, which happens to be a two-line display, you may have a D up at the top. So there's a couple things there. Depending on which calculator, you will have to adjust your mode. If it's not still in degree mode from the last time, most calculators will default to that. If you're using the block calculator, I'm just going to refer to this one for today. Excuse me, you will want to press mode, and then you'll see up here for DEG is 4. So mode and 4 if you're looking for that. So if your calculator is not in degree mode, hit pause and make sure that happens. Google how to do it if you're in a pinch. All right, so the calculator is in degree mode. We got that check done. Now we're going to evaluate what angle represented by theta, so this symbol is often used for an angle, would give us a ratio of sides equal to 0.3152. So we want to basically disconnect the sine and the theta. Very, very easy to do. If we want to find theta by itself, it's equal to the inverse sine. An inverse is often used for doing the opposite math of 0.3152. So how do you do that on your calculator? Well, it's really, really easy. First thing you're going to do using the block calculator. So if you're using this calculator, it doesn't have two lines on it. You are going to type in, I'll write the sequence here. You're going to type in 0.3152. Okay? Once that's in, I want you to press shift. And then you're going to press sign. And then you'll press equals. Okay? So shift, sign, equals. So there's our shift button. And if you look right on top of the sign in the little yellow letters, or I'm not sure if the color of the letters stayed the same when the calculator color changed, you can confirm with me, but it has this inverse sign. So that's what we want to use. And if you've done that correctly, you will get an angle theta is equal to, I'm going to just erase here and switch colors. I'm going to switch back to white for us because it's a little easier to see. So our angle is equal to 18.37 degrees. Okay? So that's how you arrange that. So you put your decimal in first, then you do shift, sign, equals. If you are using this calculator, so for this one is shift plus function. Okay, so that could be sine, cosine, or tangent. Could either be one of the three. If you're using this Casio calculator like mine, or one that has two displays, you'll just use your decimal, but you will still, in this case, I have mine as shift, sometimes it's second function. So both calculators use this shift and your function. It's just a question, do you put the number in first or the number in second? Whatever you did last time with your number, if you put your number in first last time, you're still going to put your number in first. If you put your number in second last time, you're still going to put your number in second. If that's confusing, talk to me. Cosine of an angle. Cosine of what angle will give us 0.7541. So theta is equal to the inverse cos of 0.7541, which is equal to, putting that in our calculator. So for most of you that are using the block calculator, decimal first, make sure you push shift, cosine, equals. To do that inverse, you should get 40.05 degrees. And then just a quick check with tan. I'm not going to write down the whole process. I'm just going to say the angle is equal to, and you can do this as well. In your calculator, make sure you do the shift tan. I guess I might as well write it out. 2.525. Now, in most cases for these numbers, I'm going to say keep 4 decimal places if there are 4 decimals. All right. So if you've put shift tan 2.525, you will get an answer of 68.39. All right. Now here it says, the last step says, convert the angles to degree, minute, and second form. Really easy to do. Just as a quick reminder, you take your decimal, and this works no matter which calculator. You're going to take your degrees. Okay, so you're going to take the 18.37. So 18.37, and then you're going to press the degree, minute, second button. And you would get 18. 22 and 22. Sorry, I'm having a hard time concentrating on two things to change. So that's for the very first one. For this one, it's equal to 40 degrees, 3 minutes and 12 seconds. So you can go through and you can check. If your seconds happens to have a little variation, it just might be because of rounding. I switched mine to degrees, minutes, and seconds before I rounded anything. Okay, I kept all the numbers in the calculator. And for this one, 68 degrees, 23, 40. All right, so not too complicated. So now that you all know how to use your calculator, you got your calculator working great, we're going to do a few questions. Questions are nice, easy questions as well. So we're going to solve, in this case, we're solving for the angles and the triangles. So I want to solve for angle A in the first triangle and angle B in the second. We're going to round to the nearest tenth. So that'd be the nearest tenth of a degree. But we're going to assume degrees for everything. We're not going to deal with radians. So first thing you want to do is label your triangle just like we did before. So right angle, opposite is hypotenuse. Across from the angle that's our subject angle is this one, it's our opposite. And that means this side would be my adjacent, not that it really matters to us. So when I look at this, well, what ratio am I going to use? Okay, so I've got SOHCAHTOA. I have hypotenuse and I have opposite. It should be sine. Cosine uses adjacent hypotenuse, tan uses opposite and adjacent, so they're no good. So the sine of angle A, you can use the theta symbol if you would rather, is equal to opposite goes first on the top, and on the bottom, 143.50. That happens to be equal. Now this is a situation where when you find these numbers, when you divide the two sides, keep 4 decimal places until you do your next function, especially if you're writing it down and putting it back into your calculator again later. So 0.6202. Okay, so now that you have that, that's if you retype it in your calculator, you want to have at least 4 decimal places. Now that you have that in your calculator, just save it. Okay, so don't touch anything yet. I want you to find out what angle A is. So to write it out, we'll say, well, angle A is equal to the inverse sine. So you already have this in your calculator. So all we have to do is that inverse sine. So you're going to do shift sine equals, oops, 6202. And you should have got on your calculator, I assume you have the answer by now, 38.3 degrees. All right, so that's not too bad. Now, what you want to go through is you've got these two sides. So we have opposite and adjacent, and we have hypotenuse. So we want to set up our ratio here. So we know opposite, we know adjacent, so that means we're going to use tan. So the tan of angle B is 185.2 divided by 116.3. Okay, so now that we have that in your calculator, you'll find out what that ratio is equal. So 1.5924. And then you want to find out what angle B is. So angle B is equal to inverse tan. I switched to an old habit. I used to always put these numbers in brackets. Just an old habit from university days. So bear with me. Every once in a while, one of those things sneaks back in unintentionally. And we get angle B is equal to 57.9 degrees. All right, so easy enough to do. I actually think they're probably easier than finding sides because there's a lot less rearranging involved. All you do is you find your decimal, hit shift tan, shift sine, shift cosine. For the next one, we're going to do the same kind of question. We want to find out what's at angle X, and then the second one, what's angle Y. So labeling it, I have opposite and we have hypotenuse. That's compared to angle X. So if we look at SOH, CAH, SOHCAHTOA. All right, opposite and hypotenuse, got to be sine. So the sine of our angle, I guess we could have put angle X in there. I've written theta in this particular occasion, is equal to opposite, so 10 divided by 18.5, which gives us a ratio that is equal to 0.5405. All right, now that we have that, we do our shift sine. So the angle is equal to the inverse sine, or that shift sine of 0.5405. which is equal to 32.72 degrees. Now, before you touch anything, now that you have that 32.72 on your calculator, it asks us to the nearest minute. This decimal is degrees. So to get to the nearest minute, you're going to press that degree, minute, second button, and to the nearest, and then round to the nearest minute. Minutes is your second spot. So 32 minutes, or 32 degrees rather, and this decimal 72, to switch it to minutes, you can either take a decimal 72 and multiply by 60 if you want, but just that degree, minute, second button is pretty awesome. 43 seconds, right? Or 43 minutes rather, 43 minutes. Now you get to the next one, same thing, label it. So I have hypotenuse, and here, this one is adjacent. That uses cosine. So the cosine of angle 1 is equal to adjacent 4.36 over 5.87. All right, now that we have that, find out what the ratio is. So the cosine of angle 1 as a decimal is 0.7428, and angle 1 is inverse cosine and angle 1 is equal to, putting that in, 42.03 degrees, which is equal to 42 degrees and 1 minute. Okay, so not hard to do, especially when you have that degree, minute, second button, pretty easy to calculate. Sorry, probably not a very exciting video. There's a phone conversation going on in the background here, and hopefully you folks can't hear it, but it's a little challenging to record over. 2 final questions for you to do. So the last 2 questions, we're going to put a couple pieces together in preparation for the next lesson. So the next lesson is going to look at putting multiple pieces together. So for this question, we want to solve the triangle for all the sides and angles that are missing, and we're going to match the precision that's in the question. So if degrees in the question for 2 decimal places, we're going to answer in 2 decimal places. So we're going to match the best of our ability. So the first thing I would do for this question is when I look at this and I want to find, I look at what's easiest to calculate. So sides are not hard to calculate. You did that in your last lesson, but there's one thing that's really easy. Remember I said at the beginning that the sum of angles in a triangle is 180 degrees. Well, we're going to use that principle. So angle 2 is equal to 180 degrees minus what we know. So we know we have a 90 and we know we have an 18.7, and that makes a very, very easy way to calculate that, and that gives us 71.3 degrees. We have 2 decimal places everywhere else, so we'll include 2 decimal places in our answer. Okay, so nice and easy. Now we have to figure out, well, how do we find our sides? So I would start with the easiest thing. I usually will look at angles first, because if I can use that 180 property, it just simplifies things. It's even easier than using SOHCAHTOA. Now we're going to have to use SOHCAHTOA. Why can't we use Pythagorean theorem? We could. It would be a viable option in some cases, but we don't know A and we don't know B. We need to know at least 2 sides, and we only know 1. So if you only know 1 side, you have to use SOHCAHTOA. So to find our sides, let's find A. Let's find A first. So we're going to find A, and we're going to use it, reference everything relative to the angle that we know. If I made a mistake calculating angle 2, we don't want it to change everything else in the question. So we're going to use this 18.7 as our reference. So I'm going to use it to label everything. So this is where I'm starting from. So relative to here, A is adjacent. Across from A, across from the angle that we're interested in, is B, and it's our opposite. And then here is hypotenuse. So nice and easy to calculate. So if we're calculating A first, A is adjacent. So if you're looking for the adjacent side, we'd use cosine. So the cosine of our angle, so 18.7 is equal to the adjacent side divided by 87.4. Okay, now rearranging that, you are going to find that A, remember you multiply both sides by 87.4, is 87.4 times cosine of 18.7. See if you put that in how you do putting that in your calculator. Just it's a good reminder. You do not, when you're finding a side, put a note here, when finding a side, you use no shift. Okay? If you're finding a side, you won't use shift. So no shift here because we're not looking for the angle. So it's just going to be the regular cosine. Okay, so 87.4 times, and then you'll do that 18.7 and press cosine if you're doing it all in one step. What you should get for your answer is 82.79 millimeters. Okay, not too hard to solve. That's our A. Now we want to find angle B. To find angle B, we have two solutions now. So we know that this is 82.79. So now we know two sides. And if you want to find a third side, you could use Pythagorean theorem. That would be great. I have no issues with you doing that. If you would rather use Pythagorean theorem, go ahead, try it, see if you get the same answer. It sometimes will make a variation of, say, 1 decimal place, depending on how you're doing your rounding. I'm going to give you a solution that doesn't use Pythagorean theorem and doesn't use any information that you've calculated. I've accidentally reminded. There we are. So if we go back to this 18.7, if I know I haven't calculated, I know it's right. I know the hypotenuse is right. Is there a ratio that uses an angle, hypotenuse, and opposite? Of course there is. There's sine. So the sine of 18.7 is equal to B, which is opposite, divided by the hypotenuse, which is 87.4. Rearranging, you'll get B equals 87.4 times the sine of 18.7, which happens to give you a value of 28.02 millimeters. So not hard to set up. Remember, this one, we actually didn't have to use any of the new information for this lesson. Next week or next lesson, we're going to find sometimes you're going to use one piece, sometimes you won't. Now, I do have one more example. It's the same kind of question, but in this one, we're missing more than one angle, so it's going to use more in today's lesson. So we know two sides, and we want to find a third one. And we have one right angle, but we don't know what the other two angles are. In order to do this one, there's two ways to do it, both are equally correct. You could use Pythagorean theorem here to find what is R. That's perfectly acceptable. Or you could solve for the angle and then use one of the SOHCAHTOA ratios. It doesn't really matter which one you use. I'm going to use Pythagorean theorem because Pythagorean theorem a squared plus b squared equals c squared. And you've got your a and your b and your r. So a squared, doesn't matter which one we call it, 36.4 plus 29.8 is our c squared. Putting those two pieces together, you should be able to do this at this point. Sum these two together, following order of operations. 2, 2, 1, 3 equals c squared. Okay, c, we're going to call our c as our r. Take your square root. Don't forget your square root. That's really important. C is equal to 47.04 milliliters. All right. Next thing we want to do is now we have to find our ratios. So we've got this piece figured out. To find our angles, I'm going to recommend you find one of the angles using some information that's already given to you. So if we look at, let's say angle A is a reference, okay? So we're going to start from angle A. Across from angle A would be the opposite, and next to angle A is adjacent. We know R is our hypotenuse. So we have opposite and adjacent. You probably have it all memorized to this point. Tan uses opposite and adjacent. Tan of the angle is equal to opposite over adjacent. Opposite, 29.8 over 36.4. So angle is equal to inverse tan. And that's equal, sorry, I'm going to finish one more piece of information in here. For A, this would be 0.8187, just in case you're in that middle step. So you're going to do inverse tan of 0 shift tan. Notice we're finding the angle, so we use shift. Use the inverse to undo it. 8187. And that's going to give you an angle that is equal to 39.3 degrees. We'll keep one decimal place. I wasn't very smart and I didn't give you the decimal place here. And then to find the third angle, so this is angle A. Angle B is 180 degrees minus 90 minus 39.3, which is equal to 50.7. All right. That finishes that up. Last little bit, just a quick recap. When finding angles, you always use shift. This is probably, if I was going to star one thing for you, that's the most important thing to remember. When finding angles, you always use shift. If finding sides, you never use shift. Label your triangle sides relative to the angle you know or want. That's really important. I want you to keep doing that. That's going to help you. Keep 4 decimal places until the end on your side ratios, then round once you find your side. Remember, you can still use Pythagorean theorem. Sometimes I skip it, sometimes I use it. There is choice in these. This is a situation where you're going to end up showing some more work in order to explain what you're doing. And the principle that all the angles in a triangle sum to 180 degrees can help simplify your question. So those are the 5 key things. The most important thing is, remember, when you're finding an angle, you use shift. When you want a side, you don't.